So last time we saw that finding a series converging or diverging was through finding the sequence of partial sums and then trying to figure out Sn and then taking its limit. But you noticed that finding this Sn was quite tricky and almost impossible for most cases. So there are two special cases where we can actually find the sum. So the first one is called the geometric series, and these are very important. And the second kind of series are called telescoping series, and these are not so important, but we will cover them. So geometric series are obviously far more important. So what are they? So these are the series that can be written as follows. So the series, first thing to notice for the series is that it starts from 0 to infinity. So this is very important. Most of the series that we study start from 1, but this particular one starts from 0. So a times r raised to the power k. So now if you start with k equals 0, you're going to get r raised to the power 0, which is 1. So the first term is simply a. Then you add the next one when k is 1. That means you get ar. Then you get ar squared. So the idea here is that every term that you add is just a multiple by r of the earlier term. So you add these up and we want to know what happens to it. So for example, you could have a very simple geometric series of this kind. So obviously we want to know that does it converge, and if it does converge, then what is the sum? And this can be answered as given in this result. So it says that a is not 0, obviously a cannot be 0, and r is any real number if absolute value of r is less than 1, then this series converges, and this is the formula for finding the sum. If absolute value of r is greater than equal to 1, then the series diverges. So a geometric series a r raised to the power k, it adds up and comes to a very nice sum a over 1 minus r if absolute value of r is less than 1, strictly less than 1. On the other hand, it diverges if absolute value of r is greater than equal to 1. So for any geometric series, it's pretty straightforward. The first step is make sure the sum starts from 0. So that's the first thing. Then the second step is pick the a and the r. If r is less than 1, you know that it converges and you can find the sum. If r is greater than equal to 1, then you know that it diverges. So pretty straightforward. So let's start. Let's do some examples. So this is obviously the simplest one. Everything is set up perfectly. So from here you can see that it is starting from 0, so that's good. A is 4, R is 0.25, and obviously absolute value of R is less than 1. Therefore, we can sum it up, and sum, which means the sum of this series is simply a over 1 minus r, which is simple arithmetic. 4 over 1 minus 0.25, which would turn out to be 4 over 0.75, which is 16 over 3. So these are the simple steps. Now obviously sometimes we have to do a little bit of work. So let's look at the next one. Now this is saying summation n starting from 1 to infinity e over pi raised to the power n plus 1. Now the first thing, as we said, we must make sure that sum starts from 0. So here is the sum is not from 0. It is starting at 1. So there is a very simple algebraic trick. What you do is you define your index of summation as k, which is n minus 1. So what happens is that when n is 1, if you substitute n as 1, we get that k is 0. So what we are going to do is we are going to substitute n with k plus 1, because if k is n minus 1, then n is obviously k plus 1. So let's go do that. So let's start summation. Now when n was 1, k would be 0, and obviously infinity is not affected. E over pi. Now when I see n, I'm going to write k plus 1. So k plus 1, and then there's a plus 1, so that plus 1. So this becomes series k starting from 0 to infinity e over pi raised to the power k plus 2. So what we have really done is just move the index of summation from n to k, and k starts from 0, so that's what we wanted. Okay, now let's make it to the standard form, because this is not a r raised to the power k, so I have to do that. So I have e over pi squared and e over pi raised to the power k, because k plus 2 can be split up as follows. So now this must be my a and this must be my r. Remember, let me remind you, geometric series must look like this to be able to choose a and r. Okay, so now absolute value of r is basically absolute value of e over pi, and that is less than 1. We all know the value e divided by pi would be less than 1. So therefore I can find my s, which is a over 1 minus r, which is e over pi squared divided by 1 minus e raised to the power pi, e over pi, and if you do the simple algebra, you're going to get e squared over pi times pi minus e. So this is the sum.